Welcome back to today's Explainer. We talk a lot about the latest AI updates here, but today we're taking a step back to look at the big picture of machine learning. Even if you follow AI religiously, zooming out to understand the absolute fundamental shift, like how we actually went from rigid programmed rules to this organic pattern recognition, it really gives you a powerful new lens on everything that's happening right now. So let's just dive right in.
Take a second and really think back. How did you feel the absolute first time you heard the words artificial intelligence or machine learning casually dropped in conversation? A little overwhelmed, right? The acceleration since then has been frankly staggering. But to truly ground ourselves and see where this tech is actually heading, we kind of need to strip away all the complex math and just look at the raw foundation.
Which brings us to section 1, 2 ways to teach. All right, so there are basically two completely different ways to solve a problem in computer science. Method 1 is the rulebook approach, and method 2 is the learning approach. And here's the thing. For literally decades, the entire computing world was completely obsessed with method 1. Let's break down what that actually looked like in practice. Imagine you're trying to teach a computer what a dog is by writing a very strict list of rules. You'd say, okay, it has 4 legs, it has fur, it has a tail, and it barks. Now you test it with a picture of a German Shepherd. 4 legs, yep. Fur, yes. Tail, yes. Barks, you bet. The system proudly outputs dog. The rulebook works absolutely perfectly, in theory. But what happens when the messy, chaotic real world collides with our beautiful, neat little rules? Say you input a cat. It's got 4 legs, fur, a tail, but it doesn't bark. Or what about a 3-legged rescue dog? By our strict rules, the computer just throws an error. What about a Sphinx cat with 0 fur? Or a wolf, which hits literally every rule but definitely isn't a domestic dog? The rulebook just completely falls apart. You quickly realize you simply cannot write enough rules to cover every single edge case in the universe. So, what do? We toss the rulebook right out the window and switch to method 2, the learning approach. With this method, you don't give the computer a single rule, not one. Instead, you just show it thousands and thousands of pictures. As you flip through them, you just label them. Dog, not a dog. Dog, not a dog. You're never mentioning fur or tails or barking. But something really remarkable happens. The system actually starts noticing the patterns all on its own. After enough examples, you show it a Mexican hairless dog, a totally weird-looking breed it has never seen, with absolutely no fur. And boom, it outputs dog. It figured it out entirely from the examples. And guys, this is the crucial pivot. Instead of writing strict rules and micromanaging a computer step by step, we just show it millions of examples and let it figure out the patterns itself. That incredibly simple concept, that is the exact engine behind literally all modern AI, from massive language models to self-driving cars. Moving on to section 2, why experience beats rules. To put this in perspective, for most of computing history, programmers were totally stuck in method 1. From the 1940s all the way through the early 2000s, brilliant people spent entire careers just painstakingly writing elaborate rules. You want a computer to play chess? You literally program every single possible board position. Want to block spam? You tell it to flag any email with the word lottery and 3 exclamation points. And look, for narrow, highly defined problems, it actually worked fine. But then, we asked computers to understand human language. And language is messy. Take the phrase, I can't recommend this restaurant enough. If you say that with a huge smile, it's high praise. If you say it with a sarcastic eye roll, it's a brutal review. You literally cannot write a mathematical rule for sarcasm. Language requires pattern recognition at a breathtaking scale. The old rule writing approach was never, ever going to crack the sheer complexity of how humans actually communicate. Think about it like this. Did you learn to ride a bicycle by sitting down and reading a 200-page physics manual about gyroscopic stability and exactly how much mathematical torque to apply when leaning into a turn? No way. You got on, you pedaled, you completely wiped out, and you tried again. You gave your brain real-world examples of falling and not falling, and your body just intuitively figured out the balance from experience. Machine learning is that exact, profound insight applied to computers. Experience teaches complex tasks vastly better than a rulebook ever could. Let's dive a little deeper in section 3, the mechanics of learning. So when we say a machine learns, we actually mean something incredibly specific. I want you to picture a machine inside your computer with a million tiny digital dials. When you show it a picture of a dog and say dog, it physically, well, digitally, twists some of those dials just a tiny bit. Show it a cat and say not a dog, it tweaks those dials again. Eventually, it locks into the absolute perfect configuration to tell the two apart. In the AI world, we call these dials parameters or weights. The machine hasn't saved the actual photos at all. It has just saved the exact configuration of those dials. Now, let's scale that up to today's tech. 1.76 trillion. That is the estimated number of parameters inside GPT-4. We are way beyond a million little dials now. This system has processed essentially the entire written output of humanity. We're talking books, articles, basically the whole internet. And it adjusted nearly 2 trillion dials until it fully encoded the incredibly complex patterns of human knowledge.
It's a lot like human intuition. The cat sat on the mat sounds instantly correct to us, while the mat on set, sounds completely wrong. But could you explain the exact grammatical rule for that off the top of your head? Even linguists struggle with that because there are just endless exceptions. Yet a 5-year-old knows it instantly just from being exposed to thousands of spoken examples. That is exactly how these massive AI models absorb reasoning, context, and even tone. It's all just exposure.
Which brings us to our final part. Section 4, the honest truth. Look, distinguishing the myth from the reality is where true expertise really starts. Machine learning is not magic, all right? It's simply a remarkably powerful tool for solving messy real-world problems. It absolutely does not possess genuine human understanding. It's just extraordinarily sophisticated pattern recognition. And it is certainly not unbiased or perfect. Because it learns entirely from examples, it's completely shaped by whatever data it's fed. If the dataset leans a certain way, you better believe the machine's parameters are going to reflect those exact biases. But hey, don't let the lack of human consciousness fool you for a second. By mastering this complex pattern recognition, AI today is literally diagnosing cancer from medical scans with accuracy that matches top doctors. It's translating dozens of languages in real time, answering highly complex questions from massive documents, and generating totally original images, audio, and video. Stuff that sounded like pure science fiction just 20 years ago is our current reality. These are highly, highly transformational tools. At the end of the day, it all comes down to this. You don't need to understand the complex physics of an internal combustion engine to be a great driver. But knowing the absolute basics of how the engine works ensures you don't accidentally ruin the car, right? By understanding that AI learns patterns from massive datasets instead of just following hard-coded rules, you suddenly know its true strengths, and you know exactly why it sometimes completely misses the mark.
So here's my challenge for you. The next time someone at your office, or maybe at a dinner party, is totally confused about how AI actually works, how are you going to explain it? Try breaking it down using the dog or the bicycle analogy we talked about today. Sharing these fundamental, foundational concepts really helps cut right through all the crazy hype out there. Thank you so much for joining me for this explainer, and I'll catch you in the next one.